Now in this lesson we do some work on tangents and normals. Now let's consider what a tangent and normal look like firstly. If we draw a simple parabola there, pick a point on the parabola, there is a tangent, okay? It's a straight line that just touches the parabola at that point. Now if we draw a perpendicular to that, that's known as a normal. Okay, so there we have it, a tangent and a normal. Now example 1, we're asked to find the equation of the tangent to the curve y equals x cubed minus x at the point where x equals 1. Now there's our equation. Let's write that down. Now the first thing we're going to do is find out what point we're talking about. We certainly know the x value is 1, so when x equals 1, let's substitute into the equation. We get that y equals 0. So in other words, we're dealing with the point 1, 0. Now the equation of the tangent, we need to find dy dx because that'll tell us the gradient. So firstly, x cubed, the derivative of that is 3x squared, and minus x, if you think about it, minus 1x, the derivative will be minus 1. So what we've got there is our gradient function, alright? That'll tell us the gradient of points on the curve. Now when x equals 1, let's write that down, we substitute into our dy dx, and we get that the gradient of t, the tangent, is 2. Alright, the gradient of the tangent. So we need the equation of the tangent. We're going to use this formula, a very popular formula, y minus y1 equals m outside of x minus x1, where we know the gradient is 2 and the point of interest 1, 0. So y minus y1, where our y1 value is 0, equals m, where m equals 2, x minus x1, where x1 in fact is 1. So we got y minus 0, that's simply y, expand the brackets, it equals 2x minus 2. So there we have it, that's the equation of the tangent. Second example, we need to find the equation of the normal this time to the curve y equals x squared plus 2x at the point 1, 3. So let's write our equation down. Now we know the point 1, 3 this time, so it's a little bit further on than we were last step. Equation of the normal. Well, we still want dy dx as the first step. So the derivative of x squared is 2x. The derivative of 2x is 2. Now that is our gradient function, alright? So that'll tell us the gradient. Now we've got the point 1, 3. Okay, we're dealing with x equal to 1 there, okay? That's the x coordinate. So when x equals 1, we substitute that into our gradient function, and we get that the gradient of the tangent is 4, okay? So that will always give us the gradient of the tangent. Now we want the normal. So the gradient of the tangent is 4, then the gradient of the normal is minus 1/4, okay? It's known as the negative reciprocal, okay? Because they're perpendicular. Alright, it's the perpendicular gradient. Now the equation of the normal, we're going to use the same formula there, y minus y1 equals m outside of x minus x1. So the gradient is minus 1/4, and the point of interest 1, 3. So y minus y1, where our y1 value is 3, equals m, where that's our gradient there, minus 1/4, times x minus x1, where our x1 is 1. So we have y minus 3, let's rewrite that. Minus 1/4 is multiplying by that whole bracket, and we'll have the y by itself. We've got minus 1/4 x there, and that minus 3 will go over, become plus 3. So we'll have 3 plus 1/4 will be plus 3 1/4. And that is the equation of the normal. Our third example. The normal to the curve y equals x squared plus 3x minus 4 at the point P, where x equals minus 1, cuts the curve again at a point T. And that's what we're asked to find. Find the coordinates of T. Well, you will find that we'll draw a little sketch here at some stage to make it a little bit clearer for us. But let's start by writing down the equation. At the point P where x equals minus 1, so when x equals minus 1, let's substitute that back in to the original equation there. That'll give us a y value of minus 6. So in other words, the point of interest, minus 1, minus 6. Now we're after the normal to the curve, so we always have dy dx. So the derivative of x squared is 2x. Derivative of 3x is plus 3. Derivative of minus 4, nothing. Now when x equals minus 1, let's substitute that into our gradient formula. We get that the gradient of the tangent equals 1. Now we want the normal, and now if that's the gradient of the tangent, well, the negative reciprocal, we find that the gradient of the normal is minus 1. So the equation then of the normal, we've got the point and the gradient. So we're going to use y minus y1 equals m outside of x minus x1. So y minus y1, where y1 is minus 6, we've got y minus 6 becomes y plus 6 equals m, where m's minus 1. And then x minus x1, we've got minus 1 there. So we have x minus 1 becomes x plus 1. So y plus 6, let's just rewrite that. The minus 1 expanding with the brackets. So write the y by itself. We've got minus x. The plus 6 goes over, becomes minus 6 with minus 1. So minus 6 and minus 1, all up, minus 7. So we got the equation of the normal. Now it says it cuts the curve again at a point t. Well, let's consider now y equals x squared plus 3x minus 4. Y equals, okay, now that, two brackets, let's factorize that. X and x. Factors of minus 4 to add to give positive 3 will be plus 4 and minus 1. So we can draw a little sketch here. We know it's a parabola. We know it cuts at x equals minus 4, and it will also cut at x equals positive 1. So we draw our little parabola through there. Now the point P is minus 1, minus 6. So there we have it. That's the point P. And that's the equation, or that's the graph of the tangent at least. And that would be the normal, okay? That would be perpendicular to it. And that's what we've actually found, y equals minus x minus 7. That was what we found in the first part of this question. Now the question's saying it cuts the curve again at a point T. So that would be T there. And that's what we've got to find. So, okay, that was a useful technique there. It's useful if you can draw a quick sketch just to get an idea of what is actually really happening. So we've got our line, y equals minus x minus 7. And it's basically saying when does it cut the parabola again. So we need to solve that simultaneously. So there we have it, our two equations. Now they both equal y. So let's set them equal to each other. So we get x squared plus 3x minus 4 equals minus x minus 7. Now the x squared, let's write that down. The 3x, well that minus x will come over, become plus x. So 3x plus x is 4x. We've got minus 4, but that minus 7 will come over, become plus 7. So we'll have minus 4 plus 7, which is plus 3. We've got everything to one side, so it all equals 0. So we look to factorize that. Two brackets, x and x. Factors of 3 that add to give 4. Okay, it's got to be plus 3 and plus 1. So solving that, we get x equals minus 3, or our other answer would be x equals minus 1. Now the point P is minus 1, minus 6. Alright, so there's minus 1 there already taken care of. So that would be in terms of the point P. So what we're after must be the x equals minus 3. So let's mark that. You can see clearly that would coincide with the point T there. So T certainly has x coordinate of minus 3. So when x equals minus 3, let's substitute. Doesn't matter which equation you choose, okay, because we're solving simultaneously. Which one would be easier? Probably the second one. So substituting, we get y equals minus 4. So there we have it. T therefore has coordinates of minus 3, minus 4. Terrific.